This is Spacetime, Series 25, Episode 110, for broadcast on the 17th of October 2022. Coming up on Spacetime, scientists change the orbit of a celestial object for the first time in history. Astronomers have just detected a record-breaking gamma-ray burst, and NASA's planet-hunting TESS spacecraft placed into safe mode following a sudden computer glitch. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Scientists have altered the orbit of a celestial object for the first time in history. Observations using an array of ground and space-based telescopes have confirmed that the impact of NASA's DART spacecraft into the asteroid Dimorphos successfully changed the 160-metre-wide moonlet's orbit around its host asteroid Didymos. Prior to the collision, Dimorphos took 11 hours and 55 minutes to complete one orbit around the 780-metre-wide Didymos. But following DART's impact, Dimorphos's orbit around Didymos was cut by some 32 minutes, shortening it down to 11 hours and 23 minutes. Astronomers say this measurement has a margin of uncertainty of approximately plus or minus 2 minutes, but it still far exceeds the 1% or 10 minutes scientists were hoping for. Before its encounter, NASA defined a minimum successful orbital period change around Didymos of 73 seconds or greater. But the early data suggests DART surpassed that minimum benchmark by more than 25 times. This marks humanity's first time purposely changing the motion of a celestial body, and the first full-scale demonstration of asteroid deflection technology. DART took 9 months to travel the 11 million kilometres to rendezvous with its target. NASA Administrator Bill Nelson says the mission is a watershed moment in planetary defence and shows how NASA's trying to protect the Earth from whatever the universe throws at us. Meanwhile, the director of NASA's Planetary Science Division, Laurie Glaze, described the result as an important step towards understanding the full effect of DART's impact with its target asteroid. Now, as the new data comes in day by day, astronomers will be able to better understand and assess whether and how a mission like DART could be used in the future to help protect planet Earth from a collision with a large asteroid heading directly towards us. The investigative team is still acquiring data from ground-based observations around the world. They're updating the periodicity measurements with frequent observations in order to improve its precision. Focus now is shifted towards measuring the efficiency of momentum transfer from DART's roughly 22,530 km/h collision with its target. This includes further analysis of the ejector, the many tons of asteroidal rock displaced and launched into space by the impact. Turns out the recoil from this blast debris has substantially enhanced DART's push against Dimorphos. It's acting a little bit like a jet of air streaming out of a balloon, sending the balloon in the opposite direction. To successfully understand the effect of this recoil from the ejector, more information on the asteroid's physical properties, such as the characteristics of its surface and how strong or weak it is, will be needed. These issues are still being investigated. Astronomers will continue studying imagery of Dimorphos from DART's terminal approach, and from the Italian Space Agency's Lycia Cube, the light Italian CubeSat for imaging of asteroids. This will help approximate the asteroid's mass and shape. Roughly 4 years from now, the European Space Agency's Hera mission is also planned to conduct detailed surveys of both Dimorphos and Didymos, with a special focus on the crater left by DART's collision and a precise measurement of Dimorphos's mass. Professor Stephen Tingay from Curtin University says that by any measure, the DART mission has been a tremendous success. The idea of deflecting an asteroid for planetary defense has been around for a long time, and it's even inspired numerous science fiction disaster movies. But now the engineering and science have caught up. Tingay says if in the future an asteroid's found to be on a collision course with the Earth and astronomers have enough warning, a next-generation mission based on data experience could well save the Earth and humanity from significant losses.
Pretty ambitious mission run by NASA with the involvement of the Italian Space Agency. They launched the mission, the spacecraft, back in November. The object of the mission was to collide the spacecraft with an asteroid in an attempt to change its trajectory, and this was the very first test of planetary defense techniques. That is, what you see in the movies, redirect an asteroid so that it doesn't hit the Earth. So this asteroid had no chance of coming anywhere near the Earth, but it was a test of the technique so that in the future, if there was some chance of an asteroid impact, we basically now have proven techniques to attempt to avoid that. The orbit was changed. It was changed by sort of 32 minutes, which is an enormous change. So well above the thresholds for success and, a really spectacular demonstration of the technique. There was a lot of uncertainty as to what the result of the impact would be because it depends on all of those uncertain factors. So, exactly where the spacecraft hits, how hard it hits, and really uncertain the composition of the asteroid itself and how the asteroid would react to the impact. So that the test that's been undertaken is going to provide an enormous amount of information on those characteristics, which is really going to help provide detailed planning and detailed scenarios for if we ever had to do this for real.
The ejector plume's a lot larger than a lot of people were expecting. That must be telling us something about the internal structure of Dimorphos. Obviously, much more of a dust pile or a rock pile asteroid than a solid rock.
What really surprised me about the immediate aftermath of the collision was just how spectacular the debris plume, the cloud of material that was ejected from the collision was. I'm not sure what I was exactly expecting, but I was amazed that even small telescopes from Earth could observe and pick up the enormous plume of debris that was produced by the impact. It was absolutely astonishing. There are some incredible videos from relatively small telescopes that observed the event. That was an enormous cloud of debris that was ejected, and it actually ended up acting a bit like a gun that has a recoil. So the ejector were thrown out in one direction, and that actually, the conservation of momentum means that the asteroid itself goes in the other direction. So that was, I guess, from my point of view, a little bit unexpected, and it does show that this particular asteroid and probably many asteroids are a fairly loosely aggregated small rocks and large rocks and dust and pretty loosely held together. That debris cloud has evolved into a quite long tail that is now following the asteroid through the solar system.
This is an asteroid pair which isn't a threat to Earth right now, but they still are near-Earth asteroids, and they've got lots of friends out there as well. I think the latest count is, 30,000 near-Earth asteroids?
There are a lot of asteroids, and they vary in size and therefore would vary in their impact if they ever hit the Earth. Happily, the types of asteroids that would really challenge the existence of civilization if they hit Earth, they're sort of in the 1,000 metre plus diameter range. And there's something less than 1,000 of those sized objects, and happily we know about 95% of them in a lot of detail already. There's 5% probably that we have not yet identified or catalogued, and maybe it's those that pose the biggest risk. At the smaller end of the size scale, there's a huge number of objects that could impact the Earth in the tens of metres category, not life-threatening for Earth, but would cause a bit of a mess if they occurred over a populated area. We probably only have catalogued about 30% of those types of objects, roughly speaking. So there are a lot of risks out there, but most of them are relatively minor risks. Happily, we understand pretty well the really big objects in the asteroid class.
Nevertheless, every month I do a report somewhere, either on radio or in the show, about an asteroid that astronomers have just noticed after it swept past. Obviously, a lot of these are ones coming from the direction of the sun.
The type of impact that could really threaten civilization come around with a spacing of hundreds of thousands of years. So there's no immediate threat. And what astronomers call a close call, the normal person in the street probably wouldn't call a close call. If something comes closer than the moon, we tend to get a little bit excited. It's still a long way away. And generally speaking, these are relatively small objects. So no, it's not something that keeps me awake at night. Maybe I sleep 1% better these days knowing that a mission like that was successful.
Do we need a proper Space Watch type of operation for the Southern Hemisphere? There's a very good one in the Northern Hemisphere, but nothing south of the equator.
Well, there have been some fairly substantial programs in the past that have operated from the Southern Hemisphere, and there is still some activity, but obviously there's a bigger concentration of land mass and resources in the Northern Hemisphere. So I would say yes, we probably do need more of that planetary defence surveillance from the south. I think we could do more of it all over the planet, actually. And it's not like these facilities are really all that massively expensive. Even with a relatively small telescope, some pretty effective surveillance can be done. So a worldwide network of small but capable facilities could go a long way.
That's Professor Stephen Tingay from Curtin University. And this is Space Time. Still to come, astronomers have just detected a massive record-breaking gamma-ray burst. And NASA's planet-hunting TESS spacecraft has been placed into safe mode following a sudden computer glitch. All that and more still to come on Space Time. Astronomers have just detected a record-breaking gamma-ray burst. The event, which reached Earth on October the 9th, has been catalogued as GRB 221009A. It was initially detected in X-rays picked up by NASA's Swift Gamma-Ray Space Telescope. Then other telescopes began focusing in on the source of the blast. It was so powerful that astronomers originally thought it must have occurred fairly nearby. However, follow-up observations showed that it actually originated in a dusty galaxy more than 2.4 billion light-years away. The burst was so bright, it's now believed to have been the most energetic gamma-ray burst ever detected, with up to 18 tera-electron volts. Gemma Anderson from Curtin University's node of the International Centre for Radio Astronomy Research says while its closeness makes it appear to be brighter than it really is, it's still possibly the most intrinsically bright gamma-ray burst ever seen. Astronomers are now training their telescopes on the burst's location to study the evolution of this blast and its afterglow across as many electromagnetic wavelengths as possible in order to better understand the event. Gamma-ray bursts are the most powerful explosions in the universe since the Big Bang 13.82 billion years ago. These blasts release as much energy in a few seconds as the Sun will produce in 10 billion years. Short-period gamma-ray bursts, which are less than around 2 seconds, make up roughly 30% of all gamma-ray bursts, are hypothesized to be produced by the merger of two neutron stars in a close binary system. As they crash into each other, they produce a kilonova and transform into a stellar mass black hole. Long-period gamma-ray bursts, usually lasting more than about 2 seconds, make up the other 70% of all gamma-ray bursts. They're hypothesized to be generated by the core collapse death of the universe's largest stars, in what are termed a hypernova or a superluminous supernova. These either mark the birth of a stellar mass black hole or a highly magnetized neutron star called a magnetar. This is Space-Time. Still to come, NASA's planet-hunting TESS spacecraft placed into safe mode following a computer glitch, Rocket Lab sets a new launch record, and later in the science report, researchers in Melbourne have taught a dish of living human and mouse brain cells to play pong. All that and more still to come on Space Time. NASA's planet-hunting TESS spacecraft has been placed into safe mode following a sudden computer glitch. Mission managers say TESS unexpectedly went into safe mode, halting its observations following a reset of the spacecraft's flight computer. They say the probe is stable, and observations yet to be transmitted to Earth appear to be safe. TESS circles the Earth in a highly elongated orbit, relaying data only when nearest to the Earth. The Transiting Exoplanet Survey Satellite, or TESS mission, was launched in 2018 as a follow-up to the Kepler spacecraft hunting for planets orbiting stars beyond our solar system. TESS searches for planets using the transit method, looking for a regular dip in light coming from a star, that dip possibly being caused by a planet passing or transiting in front of that star as seen from TESS's position in space. Originally designed to operate for 2 years, TESS has continued to survey the skies, identifying over 250 confirmed exoplanets and detecting thousands of candidate worlds, all adding to science's now 5,000-strong list of exoplanets. Rocket Lab has broken its annual launch record, carrying out its 8th mission this year. The company's previous record was set in 2020 when it undertook 7 launches in a single calendar year. The It Goes Up From Here night launch saw the Electron rocket blast into the sky from Pad B at Launch Complex 1 on the Mahia Peninsula of New Zealand's North Island east coast. The mission was Rocket Lab's 31st Electron launch overall, with the company having undertaken a launch every month since April. The It Goes Up From Here mission for General Atomics Electromagnetic Systems carried the Gazelle satellite loaded with the Argos 4 advanced data collection payload. That's an international Earth observation collaboration payload between several United States government departments, including NOAA, the National Oceanographic and Atmospheric Administration, NASA, and the French space agency, TESS.
Okay, all stations, we are go for out of sequence start. LD is go for launch. LD Shadow, confirm go for launch.
Confirm go for launch.
Vehicles on internal power. AFTS is green and enabled for flight.
LOX load complete. LOX system in research. All helium anti-gas ring disabled.
Stage 1, Stage 2, press for flight.
High flow engine purge enabled. Deluge activated.
10, 9, 8, 7, 6, 5, 4, 3,
Ignition.
2, 1, liftoff.
Stage 1 proportional, nominal.
T plus 38 seconds and our 31st Electron has lifted off from the pad at Rocket Lab Launch Complex 1. Electron is powering its way to orbit for General Atomics. The next milestone after liftoff is max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces on Electron are at their peak, causing the most amount of stress on the rocket.
Clear at max Q.
HV battery discharge nominal.
That's confirmation from Mission Control. Electron has successfully throttled down, passed through max Q, and ramped back up ahead of stage separation. We're currently traveling at over 2,000 kilometers per hour and at an altitude of over 20 kilometers. The next 3 milestones happen in relatively quick succession, within seconds of each other. First things first is MECO, or main engine cutoff. The 9 Rutherford engines will throttle down and then shut down completely before step 2 of this sequence. Separation of the first and second stages is next. The first stage drop away from the stage 2 body. And lastly, to continue our journey to orbital insertion, we'll see ignition of the single Rutherford engine on Electron's second stage, continuing the journey to deliver the Gazelle spacecraft to its destination.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
We've had successful MECO, separation, and stage 2 ignition. Now that we've passed through the harshest part of Earth's atmosphere, we no longer need to protect the payloads, so we can eject the fairing halves to save some mass. Fairing has successfully ejected. Stage 2 is continuing nominally with its General Atomics payload to orbit. The vehicle is currently at over 120 kilometers of altitude and reaching speeds of more than 8,500 kilometers per hour.
Guidance is nominal.
Stage 2 propulsion is nominal.
Everything is looking great at the start of our stage 2 burn. Electron powers through space at over 9,000 kilometers per hour. Those propellant levels depleting slowly, with about 76% of liquid oxygen and 75% of RP1 kerosene remaining. Those familiar with our 3D printed engines will know that Rutherford engines use batteries to power their propellant pump. But, much like anything that runs on batteries, that power source gets depleted, and soon a fresh battery is required to keep things going. The process of switching out this power source mid-flight is what we call the battery hot swap.
Stage 2 propulsion still nominal.
Hot swap successful.
And battery hot swap is confirmed, where we switched out the depleted batteries from feeding the Rutherford pumps on the second stage engine with a new one. The pumps are driven by an electric motor which provides fuel and oxidizer to the combustion chamber, spinning at a rate of over 42,000 RPM. The Stage 2 engine is powering the General Atomics payload to its destination orbit at 750 kilometers above Earth at an inclination of 98 degrees, the Sun Synchronous Orbit, or SSO. This allows the satellite to be positioned over the same location on Earth at the same solar time every day. We're well above the Kármán line now and on our way to orbit. The vehicle with payload is healthy, currently traveling at speeds of over 18,000 kilometers per hour and at an altitude of over 290 kilometers. Our first mission from LC-2 in Wallops, Virginia is slated for the end of this year, and we're all very excited to baptize our third launch pad in fire from those 9 Rutherford engines. A quick update from Mission Control for our 31st Electron mission. It all goes up from here. Electron is cruising at a speed of over 22,000 kilometers per hour, and it's in an altitude of just over 300 kilometers. With just 10% LOX remaining and 10% RP1 remaining, we're coming up on SECO or second engine cutoff ahead of kick stage separation.
Guidance on tonal, 27 seconds remaining.
SECO confirm.
Nominal transfer orbit.
Stage 3 separation confirmed.
Much like main engine cutoff, the Stage 2 Rutherford has now throttled down before the stage separates from the kick stage as it continues on to payload deployment in the next 40 minutes or so. Stage 2 and the kick stage now have separated. The kick stage will now enter what we call a coast phase. For the next 45 minutes or so, the kick stage will be in an elliptical orbit around Earth before the Curie engine ignites and raises the kick stage's perigee to put us in a circular sun-synchronous orbit. From here, we'll deploy General Atomics' Gazelle satellite.
Argos 4 joins a network of other Argos payloads now in orbit designed to collect data to provide scientists with a better understanding of Earth's physical and biological environment. This includes the planet's weather and climate, its biodiversity and ecosystems, as well as assist with maritime security, offshore pollution, and humanitarian assistance. Rocket Lab remains on track to continue its monthly launch cadence for the rest of the year, with missions scheduled to continue to launch from New Zealand, as well as the inaugural mission from the new Launch Complex 2 at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists in Melbourne have taught a dish of living human and mouse brain cells to play pong. The dish, containing some 800,000 neurons linked to a computer, were provided with electrical stimulation and feedback as they learnt, changing their firing patterns to respond to a virtual ball based on the tennis-like arcade game. The authors say their neurons took just 5 minutes to learn how to play Pong using a shared language of electrical stimulation. Interestingly, they used less and less energy as they got better at the 1970s era video game, being less likely to be aced and having longer rallies. A report in the journal Neuron says this type of computer interface with neurons in a dish will be useful for studying the underlying principles of neural circuit function. The authors say the research shows that they can interact with living biological neurons in such a way that compels them to modify their neural activity. The authors next plan to see how alcohol and drugs affect their dish brain, as they're calling it, by getting them drunk and then seeing if they end up playing Pong more poorly. The first COVID-19 vaccines designed to target Omicron are now being rolled out across Australia. The new Moderna vaccine comprises mRNA from the original COVID-19 variant as well as the Omicron BA.1. Those over 18 who have not had their recommended booster doses can choose this new vaccine. It's likely to be the first of many bivalent vaccines, with others, including one targeting Omicron BA.4 and BA.5, still under consideration for approval in Australia. So far, almost 6.9 million people have been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll is now likely to be over 15 million, with almost 620 million confirmed cases globally, while the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates that around 18 million people have now died because of COVID-19. The United Nations says the Earth's population will officially reach 8 billion people on November the 15th, 2022. That's just a month from now. On that day, Australia's population will be at 26 million, Papua New Guinea at 9 million, New Zealand at 5 million, and the rest of the Pacific and Oceania region at 4 million. Meanwhile, the North American continent's population will have reached 602 million dominated by the United States with 335 million, Mexico with 132 million, and Canada with 39 million. Across the big pond in Europe, the population next month will hit 750 million people. That's more than twice the size of the United States. A century ago, Europe's population was around 30% of the world's total. Now it's less than 10%. Russia is by far the largest country with 146 million, followed by Germany with 84 million, the UK with 69 million, France with 66, Italy with 60 million, and Spain with 47 million. But by far the most populated region on the planet will be Asia, which this time next month will house some 4.7 billion people, dominated by the Goliaths of China with 1.45 billion and India with 1.41 billion people. But by next year that'll change, with India surpassing China to become the world's most populous nation. The two Asian supergiants are followed by Indonesia with 280 million, Pakistan 231 million, Bangladesh 168 million, and Japan on 126 million people, though Japan's population is shrinking. Across the Indian Ocean, Africa remains the second most populous continent with 1.4 billion people. And Nigeria has the largest population of any country there, with 218 million inhabitants. It also has the continent's largest economy, and based on current growth rates, Nigeria's largest city, Lagos, could even emerge as the world's top megacity by the end of the decade. Africa's other most populous nations are Ethiopia on 118 million, Egypt on 107 million, the Democratic Republic of Congo with 96 million, Tanzania with 64 million, and South Africa on 61 million people. Africa also has by far the lowest medium age of any of the continents. Meanwhile, South America has a total population of 439 million, which is dominated by Brazil, which makes up nearly half of that total, with 216 million people. That's followed by Colombia with 52 million and Argentina with 46 million. The next global population milestone, 9 billion, is likely to be reached sometime in the 2030s. Last month's tragic passing of Her Majesty Queen Elizabeth II has of course reverberated around the world. Except it seems in the spirit world, where those who see the future completely miss that one. Now, one could well be forgiven for thinking that those so gifted may well have foretold of such a significant event being laid out before them there on the celestial plane. But Tim Mindham from Australian Skeptic says most clairvoyants missed it, and the few that did predict her death got the year wrong, they got the day wrong, they got the month wrong, they just got it all wrong.
Well, Stuart, as you know, we carried out a major study of psychic predictions looking at, I think it was 3,800 predictions made over the last 21 years by over 200 different psychics. These are all in Australia, across as many media formats as we could find, so pretty comprehensive. The Royals featured fairly reasonably amongst all the predictions, as they do, not quite as good as celebrities and politics and sports. But of the Royals, a lot of those were Kate and William and Harry and Meghan and all that sort of stuff. But there was a number on the Queen. I think it was about 26 who made predictions about the Queen, and I'm a bit surprised to say that 22 of them were wrong. 3 were expected results, the Queen will die eventually, and one was so vague you couldn't even sort of decide. But according to the seers, the psychics, the Queen was either going to die or abdicate. You'd be surprised in 2004, you might have missed that, 2010, 2012, 2013, 2014, 2018, 2019, 2020 and 2025, and no one said 2022. So, I mean, they're off. And so all those who made predictions were bad predictions.
The death of Her Majesty has got to be a huge event in the psychic calendar in terms of tapping into the cosmic stream of information out there. I'm surprised no one noticed it.
Yeah, we are surprised that no one actually predicted September 8th, 2022 as a death date, even though the poor Queen was sort of 96, I believe it was. So it's pretty much on the cards. That's a skeptic pun. But the fact that they didn't. I mean, obviously, a lot of them were saying, she was going to die in a certain year and she was going to abdicate and give way to Charles, etc. But they all got it wrong. And the only ones who really came close said, the Queen's going to die soon. And that's sort of, soon is a bit sort of a vague term. But they didn't do well at all. And they're now making predictions about Charles, of course, about how well he's going to go.
Oh, what's the future say about King Charles?
Well, the future is a bit mixed, actually. Some are saying he's going to sort of pass on the crown to William within the next year, or perhaps 8 years, or one was saying that he'll be around for the next 70 years, which is sort of pretty hopeful for how old he's going to be. Another one was saying that he's going to be, Uri Geller, our favourite. Uri Geller reckons he's going to be the best king in the universe, which, considering Uri Geller's success rate, is a bit of a worrying for Charles, I'm sure. But they're all over the place. Some of them are saying he will abdicate and give part of his powers to William, which means they don't really understand what abdicate means. But the classic one is Mystic Veg, who throws asparagus into the air and casts the future based on that. A bit like, the I Ching, you cast sticks, etc., but she throws asparagus. I don't know why. Maybe she's in
raw
the pay of the... I think it's raw. It'd be a bit soft if they're cooked.
Yeah.
She's probably in the pay of big asparagus, but she's reckoning that he will go next year. So there's a range.
It's before we finish up for now. Psychic Deborah Davies. She spotted something interesting in a photo of the Queen taken just days before her passing.
She did very much. This is quite amazing, actually. She was looking at photos taken of the Queen in her lounge room at Balmoral, or whatever it is, the reception room, where she had just met the new UK Prime Minister, Liz Truss. And then she was looking at some of the photos that were sort of released after the fact, and she saw these are still photos, notice, not videos. She saw in some of the photos the image of an angel. These are still photos, and you look at flames and they make a whole lot of different shapes at any time. But she saw the image of an angel, which worried her very much that something was going to happen to the Queen. And lo and behold, a day or so later, she died.
I thought it was the Grim Reaper, not an angel who came for a visit.
I think you found a hole in the theory. Well, maybe an angel was coming to collect us.
That's
right?
it, yes.
That's it, yes.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.